Hello dear students, welcome to the TEQIP Faculty initiative of Let's Crack the Gate. So, let us begin with the Power Electronics Module 2 AC/DC Phase Control Rectifiers. So, let us begin the today's class. So, till now we have studied about the single phase, full wave controlled and uncontrolled rectifiers with R load and RL or RLE load, or in other words we can say controlled constant current loads. All right. So, today's topic we are going to study about the single phase semi-converters. Single phase semi-converters. So, before moving on to that, let us have some repetition what we have studied till now. If you are remembering that we have studied about the single phase full wave rectifiers with constant current loads, which has the circuit like this. I am talking about the controlled one. So, the constant current load I am representing, whether you take RL load or RLE load, I am taking a continuous conduction mode, means constant ripple free current mode. Alright. We have already discussed about the discontinuous mode also, T1, T3, T2, T4. Let us say source voltage here and source current is here, and let us say this is the load voltage and load current is here, whose value is I naught. All right. So, this kind of circuit is also known as single phase full wave fully controlled circuit. Single phase full wave fully controlled AC/DC rectifier. This circuit is also known as this. Why it is known as single phase fully controlled? Because all the 4 switches are controlled in nature. All right. And if you remember its source current output and load voltage output, the load voltage output was like that. Let us say these are pi instants. So, if you have remember, the source current was like this, and if you mark these as alpha instant, the red one are alpha instants. So, the output voltage and output current were like this. Okay. And thus, if you take a constant load current, the source current was also like this. With this is alpha, this is pi, this is alpha plus pi, this is 2 pi, this is alpha plus 2 pi, this is 3 pi, and so on. Okay. So, in this case we have already done completed its performance parameter analysis. So, if you have remembered, its average output voltage was coming around 2 Vm upon pi cos alpha. Alright, if you remember, its average voltage was 2 Vm upon pi cos alpha. Alright, so what this average voltage is representing that as, and its range of firing angle was also from 0 to pi. Alright, so what it is representing that if you vary alpha from 0 to pi, the average output voltage will also vary as per alpha, with this means as a cosine wave, because 2 Vm upon pi is a constant factor. Alright, so if you plot this function, let us say you want to plot the V naught average with respect to alpha. So, what you will get? You will get a cosine function, but that function we have to draw only up to 0 to pi. Alright, so this is 0, this is pi by 2 and this is pi. So, we will see that the average output voltage will go like this. Okay. So, it means what? That at alpha equal to pi by 2, the average output voltage is going to be 0, and after pi by 2, the average output voltage is going to be negative, means the net average voltage of the output will be negative. Instead of these polarities, it will give you these polarities at the output. Alright. So, in that case, so at alpha equal to 0, it will be maximum value, that is 2 Vm upon pi, and at alpha is equals to pi also you will get maximum value, but negative side minus 2 Vm upon pi. Alright. So, this 0 to pi by 2 is called as rectifier mode, and from pi by 2 to pi is known as inversion mode or inverter mode. Alright, line commutated inverter mode. So, you can see that in this case, in this single phase full wave fully controlled rectifiers, what is happening, that although we are getting 2 quadrant operation, alright, that the current the voltage can become negative here. So, if you plot it here, you will get a 2 quadrant operation, that is first quadrant and fourth quadrant. But the problem is that as soon as alpha is varying from 0 to pi by 2, the average output voltage is decreasing, means very rapidly. Alright. So, but in many cases what happens, just like a DC motor case, alright, we do not require a single quadrant 2 quadrant operation, we require only single quadrant operation. Alright. So, in that case this is waste, this circuit is waste. Why it is waste? Because you cannot go beyond alpha equal to pi by 2, first thing, because if you go beyond alpha equal to pi by 2, the circuit, the terminals will reverse, supply will reverse to the DC voltage, DC machine, DC motor, and the means the direction of the motor will also become reversed. Alright. Second problem is that your alpha range is limited up to pi by 2 only. Alright, you cannot fully utilize. Alright. And third problem is that when you have to use only up to first quadrant, why to use these costly switches? Alright. So, instead of that, what we do, that if we put a freewheeling diode in this circuit, means let me make a modified circuit, that if I make a circuit like this, alright. So, if you make a circuit like this, and since load current is constant, so I am making constant current load, it means due to large inductance, any one switch has to remain or some path must be available, I naught plus minus V naught. Now, again, if you want that I need only a first quadrant operation, what should I do? If I put a freewheeling diode in anti-parallel to this circuit, so what will happen here? Just put a freewheeling diode here. So, what will happen? That we have studied this in previous lectures also, that when we put a freewheeling diode across the load, what happens? The load voltage becomes 0 when freewheeling diode comes into action, when freewheeling diode is on. And second thing, the load current does not become 0, load current does not become negative, sorry, the load voltage does not become negative. All right, the load voltage does not become negative, and no device has to remain forcefully turned on, because now the current path will be provided by this freewheeling diode to the inductor. All right. So, in this case, if you just want to know what should be the means output voltage and current, let us draw simple waveforms. Let us say this is my source voltage, like this 0, pi, 2 pi, 3 pi, 4 pi. So, let us draw the average output voltage, or sorry, output voltage, and let us draw the source current, because we have already taken load current as constant. If you want to draw load current here, you can draw here load current. All right. So, load current I am taking as constant I naught, it is a constant I naught load current. All right. So, let us mark the alpha values also, firing angles. So, let us say this is alpha plus pi, this is alpha plus 2 pi and alpha plus 3 pi. Okay. So, now let us start its working. It is very simple, that during 0 to alpha I am not taking that the circuit was prior working. All right. I am taking that at alpha, just skip 0 to alpha, take from alpha. So, at alpha what is happening, this thyristor from alpha to pi, just talk about alpha to pi. What is happening? The thyristor T1 and T4 are forward biased and thus on, because at alpha they are getting the gate pulse, and T2 and T3 are reverse biased and are thus off. So, what will happen? Due to T1 and T4, the load is in parallel with the source and freewheeling diode is also off. All right. So, load is in parallel with the source. So, what will happen? The output voltage will be same as the source voltage. So, we will get the output like this, and source current will be positive, because T1 and T4 are conducting. All right, no problem. Now, what will happen at pi? At pi, as soon as the supply reverses. So, supply reverses means T1 and T4 will become reverse biased, T3 and T2 will become forward biased, but T3 and T2 will not turn on, because until unless they do not get the gate pulse, and T1 and T4 are becoming reverse biased. So, now if freewheeling diode was not there, when freewheeling diode was not there, what was happening, that T1 and T4 has to remain forcefully turned on. That is why we are getting a negative voltage at the output after pi. But now, in this case at pi, what will happen, since T2 and T3 will not be turned on and T1 and T4 will also become reverse biased. So, what will happen, this freewheeling diode will become forward biased due to inductor LdI by dt, and the conduction will be taken over by the freewheeling diode. So, let us draw the freewheeling diode current also. freewheeling diode current also. So, till this time the freewheeling diode is 0 current. So, now what will happen at pi the freewheeling diode will take over the conduction. So, when freewheeling diode will take over the conduction, the output voltage will be 0 because the terminals are shorted. So, output voltage will be 0, but and source current, now when freewheeling diode is there, all the 4 thyristors are off. So, let us talk about pi to pi plus alpha. So, all the other thyristors are off, means T1, T2, T3, T4 are off, and freewheeling diode is on. So, in this case what will happen, output voltage will be 0, and since all the thyristor are off, it means source is disconnected from the load, that is why the source current will also be 0. It means source current will be like this. So, whatever current has to be there, that has to be taken over by the freewheeling diode. So, it means from pi to alpha plus pi, freewheeling diode will conduct. And what happens as soon as at alpha plus pi you give the gate pulse to the T2 and T3, because T2 and T3 were forward biased, alright, but because of absence of gate pulse they were not conducting. So, at T2 and at alpha plus pi you give the gate pulse to a T2 and T3, so they will become shorted, alright, and again the load and source are becoming connected, and because of turning on of T2 and T3 the freewheeling diode again becomes reverse biased, means pi plus alpha to 2 pi if you talk about, in that case T2 and T3 will be on and T1, T4 will be off, also the freewheeling diode will be off due to turning on of the T2 and T3. So, again the freewheeling diode will become open circuited, and again load and source will become connected, alright. So, output voltage will be like this, and now this in this case when T2 and T3 conducts this diode and this thyristor and this thyristor, then the source current becomes negative, alright, like this. And at 2 pi what will happen again? At 2 pi again T2 and T3 will become reverse bias and T1, T4 become forward bias, but they will not turn on because of absence of gate pulse. So, all the 4 thyristors are again off. So, means from 2 pi to 2 pi plus alpha, again T1, T2, T3, T4 are off. So, who will turn on? The freewheeling diode will turn on due to high inductor dl by L di by dt. So, because of that again the freewheeling diode is on. So, again the source is disconnected from the load. So, again the source current is 0 and freewheeling diode current will be there and output voltage will also be 0. Again from alpha plus 2 pi to 3 pi if you talk about what is happening. So, you can write here, there the T1, T4 are conducting, here freewheeling diode is conducting, here T3, T2 are conducting, here again freewheeling diode is conducting. So, the total in the total load current contribution is of switches as well as of freewheeling diode. So, as when you come to the alpha plus 2 pi, again alpha plus 2 pi T1 and T4 will become forward bias. So, this same situation become like this, and in that case again the output voltage will be like this, okay, and source current will be flowing through T1 and T4 positive, and freewheeling diode due to being reverse bias will be off. And again at 3 pi the source will be disconnected from the load and freewheeling diode will come into action. And at alpha plus 3 pi again T3 and T4, T2 and T3 will conduct. So, source current will be negative and load voltage is positive again. So, here T2, T3 is conducting and freewheeling diode current is 0, and at 4 pi to 4 pi plus alpha freewheeling diode will be conducting. So, if you repeat this cycle here, so what will be there, that the output voltage must be 0, source current must be disconnected and freewheeling diode must be conducting, alright. So, what you see here, that you are observing that in this case when we apply the freewheeling diode, your output voltage is only positive. So, this operation is a single quadrant operation. This is a single quadrant operation. Your voltage is not getting negative, and in this case if you find out the average output voltage, you will get it as Vm upon pi 1 plus cos alpha, alright. Now, in this case, but one thing you observe, that since the average voltage is not getting negative or output voltage is not getting negative, but this is coming at the cost of 2 additional thyristors. All right. So, here in this case, if you are putting 2 additional thyristors, your thyristors are not being utilized fully. All right. So, if we just try to avoid means using such a costly circuit. All right. So, here you know that if I have to use only the circuit in a single quadrant mode, then why to go with this costly circuit? Then there is another circuit, that circuit is known as semi-converter circuit. All right. So, that circuit is known as semi-converter, or in other terms it is also known as half controlled semi-converter, or it is also known as half controlled. ठीक है, one phase semi-converter or one phase half controlled rectifier. So, please note one thing, that half controlled and half wave both are two different things. In half controlled, still single phase half controlled, still the output will be 2 pulse, but half wave means output is 1 pulse. All right. So, let us make the semi-converter circuit. In semi-converter, what do we do, that we replace 2 thyristors by 2 diodes. Instead of using all the 4 thyristors and increasing the cost, we just use 2 diodes. All right, because we need only single quadrant operation. And in that circuit, an additional cost of, in above circuit, this one, an additional cost of freewheeling diode is also there. So, this is a costlier circuit if you want to utilize only for one quadrant. So, it is better to utilize semi-converter or half control rectifier if you want only single quadrant operation. So, this is a semi-converter circuit T1, T3, D2, D4. All right, and let us say this is plus minus V naught and I naught references. Okay. So, let us start its working with by drawing the waveforms. So, let us say this is source voltage. Okay. So, let us mark the instants, it is pi, 2 pi, it is 3 pi, 4 pi and so on. So, 0, pi, 2 pi, 3 pi, 4 pi. Okay. So, now, let us mark, let us say we have to draw output voltage here, we have to draw source current, and let us draw any switch current. Let us say we have to draw the thyristor T1 current, you can take any one. Let us draw 2 switch currents. All right, I am drawing IT1 and another current of diode ID2. Okay. And let us have that again I am taking the load current at like this, constant ripple free like this. Okay. So, now let us start its working. So, before that let me mark the firing angles. So, let us say this is the firing angle. So, this is alpha, this is alpha plus pi, alpha plus 2 pi and alpha plus 3 pi and so on. So, again now I start the working. So, again I am taking the instant from alpha, I am starting from alpha, okay, alpha to pi. What is happening? So, from alpha to pi you see that the switches T1 and D4 are on and T3 and D2 are off. So, in this case what will happen? T1 and D4 are on. So, obviously, the load is connected with the source, hence the load voltage is follow the source voltage. So, we get the output voltage like this. Okay. Now, what is happening? So, source current, if you try to make the source current, what will be the source current? You see that T1 and D4 are conducting, thus the source current will be positive. So, let me mark this also, T1 and D4. Alright. So, what will be the thyristor current? Yes, it is also like this, thyristor current. And what will be diode D2 current? Since diode D2 is off, so diode D2 current will be 0. Now, come to the pi instant and now let us see what is happening. Okay. So, from pi to alpha plus pi, what is happening? In this case, you see, since the load current has to be continuous, load current cannot be discontinuous. So, inductor has to get some path to conduct. So, now, but see one thing, that property of diode also. That property of diode is that as soon as it gets reverse biased, it gets immediately off, and as soon as it gets forward biased, it will be immediately on. So, when the supply is getting reversed, what is happening here is that the now supply is getting this. So, what is happening at this point, the diode D2 is forward biased and D4 is reverse biased. So, because of this, D2 will immediately turn on and D4 will immediately turn off. Alright. So, in this case what is happening, the D2 will be on and D4 will immediately be off. So, it means, but what about T3? But T3 cannot be turned on till the alpha point comes or till the firing pulse is given to the T3. So, what is happening? Say diode D4 is off now, D2 is on now. So, this load current or inductor will keep this thyristor T1 forcefully on to conduct the continuous load current. So, what will happen in this case, that D2 will be on automatically due to supply and T1 will remain forcefully on. So, what will happen? You see that this T1 and D2 will be short circuited. It means this whole branch will be short circuited. Okay. So, this whole branch is short circuited and in this case this T3 and D4 both are off. So, either you can see T3 is off and T1 is also on. So, when T3 and D4 are off, it means this branch is disconnected. So, when this branch is disconnected, it means source and load are disconnected. You can see this. That is because this is off, this is also off. So, means load and source are disconnected and what is happening? This is becoming short circuited. It means what will be happening? That this T1 and D2 will be acting like a freewheeling case. Alright, you can see that when these two become turned on, this leg will be short circuited and this leg is open circuit. So, you can remove this leg. So, this is short circuit. So, this is similar to the freewheeling diode effect. Alright, it means what? That the output voltage will become 0. Alright, and since the load current load is disconnected from the source, so source current will also be 0 and output voltage will also be 0, because this T1 and D2 shorting is causing a freewheeling effect. Alright. So, in that case what is conducting? T1 is conducting still, you see T1 is still conducting and diode D2 will start conducting from this point. Okay. So, no problem is here. Alright. Now, come to the next instant, that is from pi plus alpha to 2 pi. Now, at pi plus alpha what is happening? Immediately the T3 is getting the gate pulse. So, as soon as T3 gets the gate pulse, it will be turned on and when T3 gets on, T1 will become reverse biased and will be off. So, what will happen in this case? And diode D2 was already on, T3 and D2 will be on and T1 and D4 will be off. So, again you see that one from the positive group and one from the negative group, means again the load and source are connected, hence the output voltage will be like this. Alright, and source current will be negative in this case. Okay. And what will be the thyristor T1 current? At pi plus alpha it will be turned off, So, it will be 0, and now see diode D2 is conducting. So, you see it, diode D2 is conducting till alpha plus till 2 pi. Now, again comes to the next instant, that is from 2 pi to 2 pi plus alpha. So, what is happening in this situation? You see here what is happening in 2 pi to 2 pi plus alpha. Again the supply is getting reversed and this situation is arriving, plus upside and minus downside. So, what will be happening here? Again the diode D4 will be forward biased and D2 will be reverse biased. So, again apply the property of the diode, that diode D4 will immediately be turned on and D2 will be immediately turned off. It means D2 is off now and D4 is on now. So, what will happen? But T1 cannot be on. Okay. So, T1 will be off because of absence of gate pulse or firing edge or firing angle. So, what will happen? This inductor will try this T3 to remain forcefully on. Now, you see when T3 remains on forcefully, so what is happening? D4 is on here, T3 is on here. So, what is happening now? This branch will become short circuited. This T3 and D4 will become short circuited. So, you can mention here also, here T1 D4 is conducting, here T1 D2 is conducting, here T3 D2 is conducting, and here what will happen now? That T3 and D4 becomes shorted, and again this branch will become open circuited, this first branch will become open circuited. Again the load and source is disconnected. So, the load voltage will be same as whatever voltage is here, but this is a short circuit, hence the load voltage will be 0. Alright. So, load voltage is 0. So, what is happening? The source current is also 0 because load and source are disconnected, but what switches are conducting here? The T3 and T3 and D4 switches conducting. So, if you want to make IT1 and ID2, you will get that ID1 and ID2 both are off here. Alright. So, now coming to the alpha plus 2 pi instant. Now, when alpha plus 2 pi instant come, again T1 will get the gate pulse, and as soon as T1 gets the gate pulse, T1 will be forward biased, and due to T1 the T3 will be reverse biased, and again T1 and D4, one from positive group and one from negative group, will become conduction, and again the load and source are connected. Load and source are connected. So, again you get output T1 and D4, and again the source current is positive, thyristor current T1 current is there, but diode D2 is off. Alright. Now, again when the pi this 3 pi instant comes, so what will happen at 3 pi? Again D2 will be on, D4 will be off, and T1 and D2 will create a short circuit freewheeling effect. So, here it will be T1 and D2, source current will be 0, thyristor current will be there, and diode D2 current will start conduction, and alpha plus 3 pi, T3 is there, T3 and D2 will conduct, hence again the output will be like this. So, prior to this circuit, which one should conduct? T1 and D2. Alright. So, prior to this ID2 should be there or not? No, ID2 should not be, no, T1 and D2, yes, ID2 should be there. Okay. Sorry, before T1 D4 is T3 and D4, T3 and D4 is there. So, ID2 must not be there. Okay. So, now you observe here that in this circuit, what you are observing, let me draw the D2 also, yes. So, in this circuit what you have observed, that even after although in this circuit and what we have taken this above circuit, this one where we have used the freewheeling diode, in both the circuits the output voltage shape was same and source current shape is also same. You see carefully, output voltage shape and source current shape, see both are same, but still you see the major difference in the current or the utilization factor of the switches. In this case, when you are talking about this case, in this case during freewheeling diode operation all 4 switches were off. So, the switches were conducting only for pi minus alpha duration. That is why I said that in this case the switches were not fully utilized. Alright. But when you are using a semi converter, what you see that in each cycle, whatever output is there, each switch is conducting still for pi. See here, each switch is still conducting for pi radians. See here, from alpha to alpha plus pi means pi radians, from alpha to alpha plus pi, this pi to 2 pi means pi radians. Means in semi converter case, each switch is conducting still for pi radians. This is very important for 1 mark question, conducting for pi radians. All right. So, now in this case, but the source voltage and load current and source load voltage and source current shapes are similar. All right. So, now let us find out its performance parameters. So, now we have to find out the performance parameters, means we have to find out the DF, we have to find out PF, and we have to find out the HF or THT. So, all right. This DF means DPF, basically displacement power factor. So, for that what we need is the Fourier series analysis of the waveform. So, let us do the Fourier series analysis of the source current waveform. So, let me draw the source current waveform here again, just for reference purpose. So, our source current is like this. So, it is alpha, this is pi, this is alpha plus pi, this is 2 pi, this is alpha plus 2 pi, this is 3 pi, this is alpha plus 3 pi, this is 4 pi, and so on. So, again you see the time period is 2 pi, all right, and you can also see that the this wave is half wave symmetric. So, this wave is half wave symmetric. So, when the wave is half wave symmetric, it means that A naught will be 0 and A n and B n will exist. All right. Now, we have to calculate them, the A n and B n. So, I am taking only for the half wave. So, for half wave I am taking the time period from you can take from 0 to pi or alpha to alpha plus pi, any time period you can take. All right. So, I am writing IST is equals to, now this value is equal to I naught, that we have already mentioned, I naught from alpha, or you can see from 0 is basically 0 from 0 to alpha, and it is value I naught from alpha to pi. Okay. So, let us start its Fourier series analysis. Let us calculate directly the coefficients A n and B n. So, A n is basically 4 upon T. I am not writing the formula again, you must remember it. 4 upon T, time period is 2 pi, integration. I am just skipping 0 integration, because integration has to be break it to means in 2 parts, from 0 to alpha and alpha to pi, and 0 to alpha integration will become 0. So, I am writing directly alpha to pi I naught cos n omega t d omega t. So, this will give you 2 I naught upon n pi integration alpha to pi cos sin n pi minus sin n alpha. Oh, not integration signature. It is again, we just write it, I am writing it directly upon n pi sin n pi minus sin n alpha. Now, just apply sin A minus sin B. You know that sin A minus sin B is 2 cos A plus B by 2, sin A minus B by 2. So, you will get it as 4 I naught upon n pi cos A plus B by 2 cos n pi by 2 plus n alpha by 2 and sin n pi by 2 plus n alpha by 2. Sorry, it is not that. Let me write in next line, it will not be shown otherwise. So, this a n will be 4 I naught upon n pi 2 cos A plus B by 2 cos n pi by 2 plus n alpha by 2 sin A minus B by 2 means sin n pi by 2 minus n alpha by 2. Okay. So, that is for all n. Okay. Now, again applying the condition if n is even. So, what will happen if n is even? So, see, if n is even means the sin n pi by 2 means it will become sin pi, alright. Let us say if you take n equal to 2, so it will become sin pi minus alpha, means sin pi minus alpha, alright. So, here you can see that you cannot generalize it, because it is not going, it is not becoming 0 here, alright. Okay. And here when you see that cos pi plus, it will become cos pi plus pi plus alpha, alright. So, cos pi plus alpha and sin pi minus alpha. So, what will it become if n is, let us say n equal to 2 I am calculating. So, it will become 4 I naught upon 2 pi cos pi plus alpha sin pi minus alpha, alright. I hope I have written the formula correct. Anyway, so it cannot be generalized here now. So, I am not generalizing it. Now, let us calculate B n. So, when you calculate B n, it will be 4 upon t integration f t sin n omega t alpha to pi I naught sin n omega t d omega t equals to 2 I naught upon n pi minus cos n pi plus cos n alpha. Now, applying here formula of cos A minus cos B, 2 cos A 2 sin A plus B by 2 sin B minus A by 2. So, we will get B n equal to 4 I naught upon n pi sin A plus B by 2 n pi by 2 plus n alpha by 2 sin B minus A by 2. It will be n pi by 2 minus n alpha by 2. Okay, that is for also for all n. So, now let us write it in the Fourier series expansion form and see what is happening. So, if you write IST, it will be summation n equal to 1 to infinity a n cos n omega t plus b n sin n omega t. So, you will get IST is equals to summation n equal to 1 to infinity a n is, let me take the common things, I am taking the common terms out, 4 I naught upon n pi sin n pi by 2 minus n alpha by 2 I am taking at common, and what we are getting here cos n pi by 2 plus n alpha by 2 into cos n omega t plus sin n pi by 2 minus plus n alpha by 2 into sin n omega t. Again you can see that this formula is cos A cos B plus sin A sin B, means cos A minus B. So, we will get it as summation n equal to 1 to infinity 4 I naught upon n pi sin n pi by 2 minus n alpha by 2 into cos A minus B. A minus B means n omega n pi by 2 plus n alpha by 2 minus n omega t. Alright. So, we are getting this value. Okay. So, now just want to extract. Now, here I have to take single terms. So, let us derive the second step was to extract the fundamental component. So, put n equal to 1 and you will get IS1 t is equals to 4 I naught upon pi sin pi by 2 minus alpha by 2 cos pi by 2 minus alpha by 2 minus omega t. So, you can also write this cos this value cos pi by 2 minus alpha by 2 minus omega t as cos 90 minus theta is sin theta. So, you can write it as 4 I naught upon pi sin 90 minus theta alpha by 2 is simple cos alpha by 2 and it will become sin it will 90 minus theta means 90 minus alpha by 2 plus omega t. It means it will become sin omega t plus alpha by 2. Okay. Now, you see in this case this whole term is constant because alpha is fixed. So, cos alpha by 2 will be a fixed value. Alright. So, this whole term is constant. So, we can represent this as I m 1. 1 means fundamental. So, it can be written as I m 1 sin omega t plus alpha by 2. Okay. So, if it is sin omega t plus alpha by 2, now you can also write it as I m 1 angle alpha by 2. Okay. I m 1 angle alpha by 2. So, now our reference was V s is V m sin omega t or V m angle 0. So, with respect to this, now we want to find out the first thing, displacement power factor. So, what will be the value of displacement power factor? It is simple, cosine of angle between V fundamental component of voltage and fundamental component of current. It means the difference between these two is this. So, it is cosine of angle between voltage and current 0 minus alpha by 2. So, it will be cos of alpha by 2. So, this is the displacement power factor you see here. So, this is the difference. Okay. So, here the displacement power factor varies as the function of cos alpha by 2, and in case of full wave fully controlled, it was varying as a function of cos alpha. Alright. Now, second thing we have to calculate the power factor. So, for calculating the power factor we need it is IS1 RMS over IS RMS into displacement power factor. So, IS1 RMS you can write from here only, your value will be 4 I naught upon root 2 pi cos alpha by 2, and you have to calculate IS RMS. So, here you have to calculate IS RMS. Now, you see if you want to calculate its RMS value, this function will become like this. If you square it, the function will become like this. Okay. So, just calculate its RMS value, it will be, we can take from alpha to pi integration. So, I am taking it like this 0 to t 0 to pi, and or we can directly say 1 alpha to pi 1 upon pi, and I naught square is there omega t. Okay. So, it will be under root I naught upon pi minus alpha, okay, I naught square. So, you can write it as I naught upon I naught into under root 1 minus alpha upon pi. So, that will be the RMS value. Just put the RMS values here, I naught under root 1 minus alpha over pi. So, you have got the IS1 RMS, you have got the IS RMS, and you have got the DPF also. You will get power factor in terms of cos alpha by 2. all right, and similarly calculate the harmonic factor or the TST factor, all right. So, please calculate them and you will get that these, in case of semi-converter, the lot of harmonics are present as compared to the case of single phase full wave fully controlled rectifier. So, these are some of the advantages of semi-converters, why we use it, that this is basically signal quadrant operation, and in order to save our cost of devices we use them. And also in semi-converter the total means utilization of switches is more as compared to the freewheeling case. So, how do you like the lecture? Please comment, and for any doubt and queries please post in the comment section. Till then, thank you very much.